Hey folks, today's topic is arithmetic sequences and series. So we've talked about a sequence. Sequence is a list of numbers. A series is that same list of numbers, but instead of commas in between, there are adds in between. So there's two different kinds of sequences and series that we're going to focus on. I mean, we did it a little bit with explicit and recursive, but we're going to focus more on arithmetic, and then next time is geometric sequences. So let's take a look at this arithmetic thing. So, definition. An arithmetic sequence. Now that's what we're defining, so I'm going to underline arithmetic and sequence. Is a sequence with a common difference between consecutive terms. Okay, so there might be some words in this definition that you don't know, so let's kind of break it down. So arithmetic is a brand new word that just means adding. All right, so this is a sequence that moves along by adding. So we got a sequence with a common difference between consecutive, that means in a row. So if I'm looking at this list of numbers here, if it's arithmetic, that means that as I go from this term to this term and this term to this term and this term to this term, there's a common difference, or in other words, you would add by the same amount each time. So let's actually check that out. Let's look at this sequence and see if it does move along arithmetically. So how do you move from -4? How do you move from -4 to 1? You would go up by 5. From 1 to 6, up by 5. Another way to figure out the common difference is to grab a term and subtract the one before it. So 11 take away 6 is 5. 16 take away 11 is 5. So because these all have the same value, we would say, the question was, is the sequence arithmetic? We would say yes, because there is a common difference of 5. Notice we didn't just say yes or no. You always have to kind of make a little bit of an argument why you answered the way that you did. Yes, because there is a common difference of 5. Or you could say yes, the common difference is 5 or something like that. That'd be fine. Let's look at the next one. +2, +4, +6. Is there a pattern? Absolutely. I could tell you what the next term is. It'd be 23. 15 plus 8 would be 23. I can tell you that the next term, I can predict what the pattern is, but that doesn't make it arithmetic. It's only arithmetic if you have a common difference between terms. So if 15 take away 9 is not the same as 9 take away 5, then you do not have a common difference. So no, this is not an arithmetic sequence, because there is no common difference. So hopefully that helps figuring out whether or what I mean when I'm talking about an arithmetic sequence. So find the explicit rule for the given arithmetic sequence. So here's the sequence, and they want to come up with the rule for it. If you go back to 5.1, you remember we did explicit and recursive rules. We generated the list. Now we're going the other direction. We've given the sequence, and we have to come up with the rule. Now, you don't need to figure out this all on your own. That's why I gave you a cheat sheet. So let's go to our cheat sheet now and kind of highlight some things on here. You will be able to use this on the test. So the things that I want to point out, arithmetic, I'm going to circle that first. arithmetic means addition. It really actually also means subtraction, but I'm just going to say we're going to worry about just the addition part of it now, because I could always add a negative if I need to subtract. Remember that a sequence is a list of numbers. A series is a sum of numbers. So like I said at the beginning of today's notes, there are going to be two worlds that we're going to look at. They're the arithmetic and the geometrics. Today is arithmetic, and then we're going to fill out this part tomorrow or next time. So the rule for an arithmetic sequence, so I'm going to underline a couple of key things here. The rule for an arithmetic sequence. So when we're looking for a sequence, so I'm going to first decide, am I in the arithmetic or geometric world? Once you figure out your arithmetic, then there are two types of rules. There's the arithmetic sequence, and then down here, the arithmetic series. We're going to get to that one later in the notes. So what are the characteristics that we really care about here? What are the things that we're going to highlight? Well, there's two things that you want to really look for. The rule for an arithmetic sequence with first term a sub 1 and common difference d. So those are the two things that you've got to find. You've got to figure out what the first term is and what the common difference is in between them. And then we just have to plug and chug into this rule. So let's see. Let's go back to our notes here. What's the first term? Well, that's pretty easy to identify. In example 3, the first term is a sub 1 is negative 16. What's the common difference? To find the common difference, you can grab any term and subtract the one before it. So I grab any term, negative 13, and subtract negative 16, you would get positive 3. The other way to think about it is just look at how this moves. How do you go forward? How do you go from one term to the next? For me to go from negative 10 to negative 7, I would have to add 3. So my common difference is 3. Now I've got these two values. That's all I need to write my rule. A sub n equals a sub 1. So for us, our a sub n equals a sub 1, negative 16, plus the difference times the quantity n minus 1. So plus the difference times the quantity n minus 1. There we go. So all I did was plug and chug into from my cheat sheet, the rule for an arithmetic sequence. Now, I do want you guys to clean these up since they're so easy to clean up. I mean, I would expect you to distribute and combine like terms. So this would be negative 16, 3n minus 3, and then we would get a sub n equals, we usually like to put the variable first, minus 16 minus 3 would be negative 19. So now if I wanted to find any term in the sequence, like the 25th term, I could just plug 25 in for n, and we've got our sequence, or our term, I should say. All right, let's have you try the next one on your own, see how you do. Hopefully you paused and you got it. My first term is the number 60. My difference, okay, 60 to 58 goes down by 8. Does that keep going? Yep, down by 8. Yep, down by 8. So my difference is negative this time. Now I'm just plugging and chugging into that formula from our cheat sheet. So a sub n is equal to first term plus common difference. Now if you wanted to just write subtract 8 here, I'm okay with that. But then it's always n minus 1. Clean it up. Combine like terms. This time I'm going to put the variable second because it's negative. I would still give you full credit if you wrote negative 8n plus 68, but I'm going to put the 68 first so I can keep that subtract in the middle. Pretty straightforward, huh? All right, the next two are looking at, I'm just giving you less and less information. We're going to try to use that information to still write a rule. So here I am again. I'm going to write this rule. I'm trying to use this formula that we have on our cheat sheet. But the only information I gave you was the fourth term, which was 25, and then I gave you the 13th term, which was 70. So I'm going to start off by thinking about how many gaps there are between these terms. In other words, how many gaps are there? How far apart is a sub 4 and a sub 13? You know how we did these little differences here, plus 5, plus 5, plus 5? So my first term and my fifth term have 4 gaps in between. So that's what I want to figure out. How many differences, I call them gaps, how many differences were there between the terms? Well, let's see. If I start with a sub 4, I would have to add, okay, I need to get to a sub 13. So a sub 4, a sub 5, 6, 7, 8, 9, 10, 11, 12, 13. So I needed 9 gaps to get to 13. So a sub 4 plus 9 differences would take me to a sub 13. Now, you might say, how does this help us? Well, they told us 2 of these values. They told us that a sub 4 was 25, and they told us that a sub 13 was 70. So I can now substitute those values in here. A sub 4, they told me was 25, so I can put a 25 in there, plus 9d equals, and they told me that a sub 13 was 70. Now I can use my algebra skills to try to get a value for that difference. So I'm going to subtract 25 from both sides. I'd have 9d equals 45. Divide by 9, and I get that the common difference is 5. Now that's half the story there. That's good. We found some important stuff, but that's not the answer. We've got to also find these 2 things. So we figured out the common difference. Now we got to find the first term. The way there's lots of different ways to do it. The best way I think of is to just work your way backwards. I'm going to start with a sub 4, and then I'm going to work my way backwards with the difference until I get to a sub 1. So a sub 4 is 25. A sub 3, if the common difference is plus 5, that means as I go forward, I would add 5. If I want to go in reverse, I would subtract 5. Then a sub 2, subtract 5. Then a sub 1, subtract 5, and I get a sub 1 equals 10. Now I can take these 2 pieces together, and I can write them into my formula. So a sub n equals first term, which was 10, plus common difference, which was 5, times the quantity n minus 1. Let's see if we can do this all in our head here. This would be a sub n equals 5n. That'd be 10 take away 5, which would be 5. All right, I'm going to encourage you to pause here and try to do the next one on your own. All right, let's see how you did. So a sub 3 is where I start, plus, okay, between 3 and 8. I always need to use my fingers. I don't count a sub 3, I count the gaps. So a sub 3, a sub 4, a sub 5, a sub 6, a sub 7, a sub 8. So that's 5 gaps. There are 5 differences until I get to a sub 8. A sub 8 and a sub 3 were given to me up here, so I can plug those in. A sub 3 is 7 plus 5 differences equals negative 13. Now I can do some algebra. I'm going to minus the 7, so 5 differences equals negative 20. Divide by 5, I get difference equals negative 4. Okay, so now we've got half the battle. We need to figure out the first term, though. We're not done yet. So a sub 3 was 7. So a sub 2 would be, okay, this sequence moves forward by subtract 3. So if I want to move backwards, I have to add, subtract 4. I'm looking at a 4 and I said a 3. Moves forward by subtract 4. So if I want to move backwards, I have to add 4. So 7 plus 4 is 11. 11 plus 4 is 15. So now I have first term, I have common difference, I can start plugging in and chugging. So a sub n is equal to my first term, which was 15, plus my common difference, which was negative 4, times the quantity n minus 1. Now I can start to clean some things up here. Can I do this all in my head? 15, negative 4, 15 take away 4. No. Negative times a negative is a positive, plus the 15 would be 19 minus 4n. What do you think? Now, in today's notes, notice they're called sequences and series, so we still have to talk a little bit about the series. Now look, if you want to plug and chug, we already talked about summation notation where you'd plug in 1, then plug in 2, then plug in 3, and it'd go on forever up until 25. If you want to do that 25 times, great, you'll get the right answer. But if you'll notice, some mathematicians have figured out a shortcut for us. The sum of the first n terms of an arithmetic series is n over 2 times the quantity a sub 1 plus a sub n. So let's leave a little note to ourselves about what these things are. What does n stand for? N comes from this. That's the number of terms. How many terms do we have in the sequence? That's this value here. Then we also have a sub 1, which we've talked a lot about. That's called the first term. And then we get to something a little bit sneaky, a sub n. Well, remember, there are how many terms? N. So I would go from 1, and then the last number that I would plug in is n. So if a sub n is the last number that I would plug in, that is also the last term. Now you find the first term by plugging in. How do you find the first term? We would plug in 1. How would you find the last term? Plug in n. And if you want to add this to your cheat sheet, I don't care. That's fine. I know you're going to be able to use it on the test, and I'm okay with that. So what do I have to find if I'm going to be able to use this shortcut? I've got to find how many terms they're going to be. I need to find the first term by plugging in 1, and I need to find the last term by plugging in n, and then getting their sum calculated. So let's see. What do I need? What did I say I needed? First term. So let's go with, what haven't we used yet? I'm using a lot of green. How about a nice off orange? So a sub, nope, n. How many terms are there? From 1 until 25. So there are 25 terms. Who is my first term? I find the first term by plugging in 1. So 2 times 1 is 2. Take away 7 is negative 5. I find my last term. In this case, that would be a sub 25 by plugging in 25. So we plug in 25. That's 50. 50 take away 7 is 43. Now I'm going to take these values. I'm going to plug them and chug them into my formula. So my formula is, what is it again? N over 2 times the quantity a sub 1 plus a sub n. So my sum would be number of terms, 25 over 2 times the quantity of the first term plus the last term. Grab your calc. 25 divided by 2 times the quantity of negative 5 plus 43 ends up being 475. You try the last one on your own. All right, let's see how you did. How many terms? 20. First term, plug in 1, so that's 1, that's 3. 43 take away 3 is 40. Last term would be the 20th term this time. So I need to plug in 20, that's 60. 43 take away 60 would be negative 17. Now, plug and chug. Number of terms over 2 times the quantity of the first term plus the last term. 20 divided by 2 is 10, obviously. Multiplied by 40 minus 17, I got 230. All right, folks, so don't forget to refer back to your Unit 5 cheat sheet. You can't add anything to this, but you can add the stuff that we already put together. Good luck.